All right, so last problem. The volume of a cone is increasing, so I know I saw the word increasing. It means this is probably a related rate. So if it's related rates, let me get myself ready. All right, so information that we're given that the volume is increasing at a rate of 4 pi cubic inches per second. At the instant when the radius of the cone is 2 inches, its volume is also an instant right then, 8 pi cubic inches. And the radius increases at 1/3. All right, there's a lot of given information. So let me move the question. And the radius is changing at the rate of 1/3 inch per second. All right, so let's go through and figure out what the question was for this problem. Part A wants to know what's the rate of change of the area of the base. Well, the base of a cone is a circle. Therefore, the area of a circle is pi r squared. Therefore, dA dt is equal to 2 pi r dr dt. And I think I actually have enough information to do that. So 2 pi, the instant that the radius is 2, and dr dt they gave us was 1/3. So we get 4/3 pi and inches squared per second. So there's our part A. Part B, I'm going to actually steal this, says, at the instant when the radius of the cone is 2 inches, what is the rate of change of its height? All right, let's see, the height. So in this case, the question is now dH dt. So the formula would be the volume formula, 1/3 pi r squared h. I think they gave us enough information where we may be able to use both the radius and the height. And how can I tell that? Because they gave us information about the radius and they gave us the height as the question. So let's see where this takes me. So I'm going to do dv dt. I'm going to actually need more space than that. So let me back up a little bit. dv dt equals, leave the first, derivative of the second, plus leave the second times the derivative of the first, all right, so let's see if we have everything we need. dv dt is 4 pi. I'm going to simplify as I go. The radius is 2. 2 squared is 4, so I get 4 right here would be where the 2 goes. I get 4 pi 3. dH dt is my question, so I want to leave that alone. Plus, we're stuck for a second because I don't know height, but I do know that this here would simplify to 2 pi r over 3 times dr dt. The radius was 2, so I actually get 4 pi over 3. dr dt was 1/3. So my only issue is the fact that I don't know the height. So that means that I must be able to find it, or maybe I made a mistake somewhere. So I'm going to go back and look and see. Well, if you remember, we were dealing with a cone. And when you have a cone, remember, we have similar triangles. So we have R and H. Now, the volume 8 pi I actually never used, but it looks like maybe that might help me to find the height at the instant. So volume is 1/3 pi r squared h. If my volume was 8 pi, when my radius was 2, could that find me the height at the instant? And it looks like it can. So let's go and look. Let's see. We actually get, divide by 4, which would be 2, multiply by 3, which makes 6, is actually my height. So what did I figure out? I figured out not that the height is always 6 inches. I found that at the instant, I can add on that the height is 6 inches. I didn't necessarily know that I was going to need that, but now I figured out that I did. So we get 4 pi is equal to 4 pi over 3 dH dt plus 6 times 4 pi over 9, 2, 3. So we get 4 pi minus 8 pi over 3 is equal to 4 pi over 3 dH dt. See if I can squeeze this in here. And now we get that 4 pi over 3 is equal to 4 pi over 3 dH dt. Therefore, divide, and we get that dH dt is 1. You actually could have done this problem by using the proportion from the beginning, the r over h is equal to, and finding how much the height is at that instant, and you could have done the whole problem without using dr dt or using the radius at all. That actually would have worked. So I get 1 inch per second. So again, what I was saying is this portion that I did really late in the problem, I could have done at the beginning, and I could have eliminated the radius by using the proportion r over h is equal to 2 over 6. And we could have used that from the very beginning, and you wouldn't have had radius in your formula, which would mean that your derivative would be a lot easier and would not have a product rule. But there is part B. And then part C, see what this guy says. At the instant where the radius of the cone is 2, what is the instantaneous rate of change of the area of the base with respect to its height? Huh. Interesting. So that's actually, So we have done this maybe twice in class, but I can actually find dA dt and divide it by dH dt. Why can I do that? Because the dt's will cancel and leave me dA dt. Or, sorry, dA over dH. Therefore, at that instant, if you remember, we found dA dt back in part A. I'm going to go back and find that value, which was 4/3 pi. The HDT we just found a second ago was 1. Therefore, we end up with still 4/3 pi. The units would be area unit is inches squared, height unit is inches. So really my answer is 4/3 pi inches. There we go.